All right, so let's put some of these permutations and combination calculator stuff to the test here. So we're going to be given a set of problems, and our biggest thing to do is decide if it's a permutation or a combination. And we're just really kind of looking for those keywords using really close reading skills. So for this first one here, example 8, we're playing radio songs. We've got 9 total, and we're choosing 4. And I see that word arranged right there. Arranged tells me that we're putting something in order. We're arranging it. So this is going to be my keyword that I'm using, order. That's a permutation. And remember, the largest number comes first. If you don't do that and you switch it the other way, you're going to get an answer that you know is not right. So kind of a catch safe there in the calculator. But the largest number is going to come first. And pretty easy to type in, and we get our answer. Just make sure when you're going to show work that you write all of that out, the entire thing. Tell me what you typed in your calculator, so that's that first part with the P, and then what the calculator gave out. That way I can get back and give you partial credit. If you chose the wrong one, so maybe you chose the C, but you got the right answer for the C, then I can give you some partial credit. But if you don't tell me what you typed in, some of these, there's too many choices for me to try to figure out what you might have typed in. So for your work on these, show me that entire thing that I have written out and highlighted, what you typed in, what the calculator gave you out. All right, looking at this example 9. Here we've got 8 people all in a race. We're going to assume we can't have any ties, and how many different, this one's really straightforward. It says the word order. I know it's going to be a permutation. The only thing that's a little tricky on this one is they don't give me 2 numbers. I only have the number 8. That's because all 8 skiers we're going to assume are going to finish the race. So all 8 skiers start, and we want to know the order that all 8 finish in. So we're going to use that same 8 again. I'm going to type that in my calculator. I already kind of had these pre-typed in my calculator, so I know I'm going a little bit fast, but you do want to make sure, stop, pause the video, make sure you're getting the same answer out of the calculator that I got out when I typed mine in. All right, so looking at example 10 here, we've got a manager of an accounting company wants to form a 3-person advisory committee. So my keyword here is the committee. A committee is a combination. Remember, I remember that because they both start with C, committee and combination. If you're in a committee, you're the same no matter if you're the first or the 4th person chosen on the committee or however many people might be there. Everybody has the same role. So this is going to be a combination. My largest number is 20. My smallest number is 3. And I'm going to type that in. Again, just to make sure we're all clear, we're going to write all of that on our paper for our show work, not just the answer, but also what we typed in to get the answer. All right. I'm going to skip down and look at 12 right here, because this one you might not know right off if order matters or not, and that's why I like to go over it in the notes before we get to a homework or a quiz or anything like that. For lotteries, almost all the time, unless I say otherwise, the order does not matter. There are lotteries where it can matter. Those are special times, and we're not going to talk about those unless I say somehow that the order matters and come up with a question. But in general, if we're just talking about a lottery and don't say anything, the order does not matter. The numbers 1 through 44, that would include 44 numbers, and we're choosing 5 of those numbers for my final answer there. So if you didn't know that about lotteries beforehand, that's okay. Now you do. So now you know what we're looking for here. All right, so what I want you guys to do is pause. Stick with me for just a second though. I want you to try example 11 and example 14. I know they're on 2 different pages, but example 11 and example 14. One of these, the order matters. One of them, the order does not matter. So one's a P and one's a C. If you're not sure on one of them, try to think about the other one and then kind of process of elimination there. So stop and try 11 and 14. And then once you think you have the answers for those, go ahead and hit play and we'll go over those 2. So go ahead and hit pause. All right. I think the easiest one of these to figure out is maybe 11. It's okay if you started with 14 though. Thinking about naming something, the order matters when you name something. Like a story I always tell is when I first started dating my husband, his name's Michael, but I would always mistype his name, the A-E-L at the end. My fingers had to learn it and his name wouldn't pop up because I mistyped it. So the order, like if you just switch 2 of your letters in your name, you don't have the same name anymore. Like your computer won't open up if you go to type that in. So order is important with names, phone numbers, passwords, any of that stuff. So this one, the order is going to be important. So I'm going to use a P. It tells me there are 24 letters in the Greek alphabet, and I'm choosing 3 for my fraternity. Oops. And that's going to give me 12,144 for my answer. So again, names, phone numbers, passwords, the order is always important for those. I told you to try 14 as well. I said one was a permutation and one was a combination. So I kind of gave away what this one's going to be. The order is not going to matter. For playing cards, and you can think back to Go Fish back in the day, when you were little, if you picked up a card, you can change the order in your hands. You can make the 2 5s sit next to each other or whatever it might be. So order is not important. If you didn't know that about cards, now you do, just like you knew about the lottery. So the order is not important when we're playing just a regular hand of cards here. And we know there are 52 cards in a deck, and we're going to choose 5 of them. And like I said, that's going to be a combination. The order is not going to matter. I'm looking at what my calculator gave me. I'm going to get 2,598,960. All right, so that brings us to our last problem. And this problem is going to go hand in hand with the next section. So our next section is going to deal with permutations and combinations more. And we're going to start getting really huge numbers because I'm going to combine them together. So you're going to see on this one, I'm going to have 2 different combinations. We're going to keep this idea up for our next section as well. So for this one, how I know I'm going to have 2 different combinations is because I have 2 different sets of things. Technically, what I'm doing here is I'm doing a fundamental counting with a permutation, kind of combining those together. It's like the ultimate problem for this section. So think about our units here. We've got teachers, which I'm going to highlight in one color, and we've got students in another. We have to keep the teachers with the teachers and the students with the students. We're totally keeping them separate. It is not biggest number goes with biggest number. It is by the units. So for my first one here, I'm going to do the teachers. I'm taking as committees, so that's how I know I'm using a combination because it's a committee. So there's 7 teachers and I'm choosing 2. Remember, keep the units together. I'm going to multiply that. The students, there are 30 students and I'm choosing 5 of them. Biggest number does come first, but we have to do it for the teachers separate than with the students. The order doesn't matter. If you want to put the students first, you can, and then the teachers. Since it's a multiplication, order doesn't matter. 5 times 3 is the same thing as 3 times 5. So you can change the order, just make the 30 and 5 go together and the 7 and the 2 go together. You can type this in all together at one time. I would kind of suggest doing that as we get to really large numbers. Scientific notation could mess you up if you do it separately. In this particular one, you can type it in separately. So if you were to, for this first one, you would get 21. For the second one, you would get 142,506 if you wanted to type it in separately and then multiply them together. Or you can just do it all together at once, which is the way that I usually do it. We would get our final answer of 2,992,626.